Okay, so let's get things started. This is the TDS building. We all know that. If you have had the first draft, you have already calculated the amount of energy that we can get from PV panels on this open rack array that we have, this roof. If you compare this option to the option of having um different rows here on the roof without having this additional structure, that for sure will cost a lot of money. But I think we all agree, looking at the reports, that this is the better option. Always, this is the best option in terms of energy efficiency. Probably it's more expensive, but it will be, we will have to work with this economic analysis to see the payback period and how much time it takes to recover the initial investment or the money that we have paid upfront. Okay, but sure, it can be 5 years, 6 years, 10 years, 25 years. Everything that is below 10 years, it's fine. But in terms of energy efficiency, this is the best option, better than having different rows here on the roof. But before starting this building, I want to show you what we can do with the PV watts, because there are new features in these PV watts, and I think it's interesting. We are used to looking at this. Okay, so this is the monthly performance and the total annual performance, and this is the energy that we can get, this AC energy, alternating current energy, in kilowatt hours. So with the PV array, you know that we can go back. We can define the system size, we can define what module we're working with, the array type, open rack or roof mounted, yes. And those are the angle and the orientation. Here we can select whether it's a residential or a commercial building. Well, if we are analyzing the TDS building, it would be commercial. And here we have some information about the economic analysis. Here we have dollars per kilowatt hours. Well, that's the only information that we have. So we need to go to the electric company, or we need to go to the state of New Hampshire to see what's the average price for kilowatt hour. You can find out this by looking at your electricity bill, and you know what you're paying for it, because the electricity bill is in dollars per kilowatt hours. But I don't like this analysis from PV watts, so that's why we were using the PVF chart. Anyway, when you are you have fixed all these numbers, then we can go, and we have this annual analysis. This is the annual, the total energy, and this is the monthly. But we can go even farther with these PV watts, and this is something new, and it wasn't like this at least last year, I don't know, but they have implemented this hourly analysis. And then here you can download results. You can download the monthly results, this, or the hourly results. Okay, so let's do this. Let's click here. What is it? Yes, I can see, no, you're there, don't worry. Okay, so let's click in this hourly analysis, and we download something that looks like a PV showing folder, and I'm going to copy this and okay, so this is the PV watts hourly. I always recommend you give a better name, but anyway. So we can open this, and yeah, we do have this overwhelming information. But if we look at it, it's very easy to understand, because this is the hourly energy production. So we always have to go to this column, the AC system output. Here we have the DC, the cell temperature, the irradiance on the hourly irradiance on the panel. So there's a lot of information. We have the ambient temperature, we have the wind speed, the beam irradiation. So we have a lot of information, but this is what we are interested in, this column. Okay, so this is the AC system output. We have an output, a monthly output. In January, it's 444, okay, kilowatt hours. But in this hourly output, this is month 1, January, day 1, hour 1, 2, 3, 4, 5, up to 23. And then here we have month 1, day 2. And if we scroll down, month 1, day 3. And if we go down, this is month 5, May, day 27. And the hours from 0 to, so here easily we can get the information of how much energy we are producing every single hour on every single day. So what is the energy production on May the 27th at 6 a.m. 247 kilowatt hours. By the way, this is not kilowatt hours. This is watt. It's watt. It's not kilowatts. Okay. So if we want to, we can always. That's the good thing of having an Excel file. We can have here kilowatt hours, and we know that a kilowatt equals this one divided by 1,000. Okay, so we go all the way down. Okay, and here we have kilowatt hours per kilowatts, kilowatt hours. Yeah, this is watt hour and this is kilowatt hours, and this is the total. Okay, so this is the total yearly production. It's 6,473 or 74 kilowatt hours per year. So if we look at the monthly, it's 6,474. Okay, so this number should be the same as this one, and it is. It's, if we round up, if we go to format and we don't use decimal places, it's 6,474. Okay, that's great, because now we can analyze this using a graphic. Imagine that I want to analyze the what happens in January. Okay, so I only have to select all these data up to month number 2. Show. Yep. So this is January the 21st, and this is February the 1st. Okay, so I analyze this. I insert a chart, and I can use this one. Or I don't know. Let's see this one. No. Insert. Okay, this one goes back. I can make it bigger to see what's going on. And this is the, I think we have a lot of information here, because here we can see these are different days, first, second, third, fourth, fifth, and here we can understand what's going on every single day. We should have 31st days, and here we don't have any sun. This is a cloudy day, so in the days in which I have the very low production, those are cloudy days. But when it's sunny, I have quite good production here. Okay, so we can analyze this, and this is the maximum, and this is 0. If we want to analyze what happens in July, or if we want to analyze what happens just a single day, okay, so today is April the 28th. So let's go to April. Okay, this is April the 28th. It starts here and ends there. So I have to select all this data. I can insert one of those, and this is what happens today. Okay. If we're analyzing our building, well, today we don't produce anything during the night. Makes sense. And then this is the profile of the of our production. Yes.
How does PV Watts know this? Is it from like historical data?
Yeah, you have historical. For sure, PV Watts doesn't know what's going on today. So today is cloudy, and I don't know if this is a cloudy day or not. But they have I mean, programmers or people working with this. They are working with statistics. So I don't know when was the first time or the first year in which the weather data was recorded in King, in 1921 or in 1877, whatever. But we have all this data, and then they have an average. Can we rely on this specific day? Well, I mean, the average on April the 28th will be like this. Does it mean that today, without any sun, we are producing this? Well, maybe not today, but the average on every April the 28th, it will be something like that. But this is how this software works. They don't analyze actual data right now. So they have a huge database, and they just have the average solar irradiance, temperature on that specific day. Okay, but if we have this on April the 28th, okay, we're working with that day. We can even compare something different. You know that on the PV chart, the PVF chart, you could type the electric demand or the electric load. We can do it, okay? We can do it here. If we know that the schedule of the building, if the building starts operating at, let's say at 7 a.m. Okay, so at 7 a.m., if we know the load of this building, it can be, I don't know, 2.5 kilowatt hours. And then we make it 2.5, but in the afternoon or in the evening, we have 3, and then we have 1, and then we have 0.5, and after that, we have 0. And if we select data, we add a new series. Well, we need a name here. And then we select this column. So here we can compare the energy consumption and the energy production. And that's good because here we can understand whether we are having a zero energy building or not, when we have to sell energy and when we have to buy energy. So when the production is higher than the consumption, we have to sell energy. But when the consumption is higher than the production, then we have to buy the energy from the grid. Okay, so I think even with using PV watts, we can have all this information that we had with the PVF chart. And now I find that PV watts is more intuitive. The only thing, because we have all this data, the only thing we have to insert is the daily load. But once we have calculated the daily load one day, we can just copy, and because most likely we will have the same load every single day. Okay, so then we can have this analysis throughout the. Let's do this. In January, where was the, oh, it's here. If this is January the 26th, okay, imagine that I have the same load every single day. Now I copy this. Okay, then on this chart, I can select data. I can add a new series. The name of this can be demand. I can select all these columns. No, sorry. I have to select the orange one. And now I can compare the energy production and the energy demand every single day. Okay, so the demand is going to be the same. So we open the building, we have the same demand, kind of, but the energy production is different. So in this day, on this day, most of the demand is covered by the PV array, but on a cloudy day, we have the same demand and we don't have any production. Okay, so this day we will be buying a lot of energy from the grid. On this day, at this moment, we will be selling energy. That at this moment in the evening, we will be buying energy from the grid. So that's why in this PV analysis, you see that the same day you can sell energy and you can buy energy. Yeah, sure. It depends on the demand and depends on the solar radiation that we have every single hour. Well, I think this is quite useful, and actually I like this more than the PV F chart. So probably we will use this one. The only thing is that we don't have the economic analysis, the payback period, but Anyway, we're not using the economic parameters because we don't know about discount rate and all these economic parameters. That okay, so if we want to analyze this option from the economic point of view, we should use the PVF chart. But just for analyzing the energy, I think PV watts it's much better because we can export all this information on an Excel file. So part of the final project will be based on this. So you will have to calculate this on PV watts. Then you have to download the hourly production, and then we will have to prepare some graphics. I will provide you with the demand. Well, I won't provide you with the demand. You will calculate the building demand with Revit, and then we will compare the energy production and the energy demand by using this Excel file that we have downloaded from PV watts. So that will be the plan. It sounds like terrible, but it's not that complicated because you only have to come here. You have to calculate the DC system size of the PV array that we have on the roof. We have the angle, the same angle that you have calculated with Revit. And then here you have the monthly performance. And with this option, we can download the hourly performance as well. And I will have you create a graphic on a specific, not a day, but a specific month or week to see how things are going. So this is about the PV watts. Now we have to work with Revit because we need to understand the electric demand of this building. Okay, so we are going to analyze this building. Before analyzing this building is too big, and the energy analysis will take not forever, but I have done this at home, and it takes like a couple of hours. Okay, since we are ready, we are done with the building, and then we click on the energy analysis, it takes a couple of hours. And we don't have a couple of hours, so today I'm going to show you what to do with a simple building. This one. I'm going to save it as 28. Energy analysis. Okay, so I showed you how to work with spaces. We have to make sure that the space is placed on the right place. If we look at the section, we have to make sure that the space goes from the floor to the roof. We have to make sure that we don't have any or the boundaries are not rooms without spaces, because it will be a mess. So everything has to be, even if we have two different rooms, we need to assign spaces to all these rooms. And now we have to work with the space itself. Okay, so if we go to level 0, we select the space, and here on the properties windows, we have to work with this. So first we can name it. So we can name the space office 1. We did this in the TDS building. We named the spaces that we are going to analyze: the CAD lab, the studio, the lobby. So we named those spaces. So here we can change the name. And then we have to make sure that everything that is written here. Especially, okay, so here you see that we have a lot of things. We have electrical loads, design HVAC, other loads, but this is the electrical loads. By default is 0. So here we will have to change something. Here we have the dimensions of the space. We have the area, the perimeter, the volume. And here we have the mechanical flow. Well, we can use this if you took systems. We changed that, but we changed that so that we could analyze you remember that we can click on a duct and then we can see how many CFM this duct has. And then by tracing this duct, we can, at the end, close to the air handling unit, the total CFM should be the total CFM that we have designed. Anyway, we are not going to use this because now we are not designing the mechanical systems, but with this mechanical flow, we can assign a specific flow CFM to that space. We have the number, we have the name, and here we have the energy analysis. So in the energy analysis, I don't know, maybe by default you can have a plenum, but you have to make sure that this is an occupable space. Okay, so that means that it's not a storage room or a mechanical room, or so it's something that it has a use, and there are people living on that space. And those people are living or are occupying this space over the specified schedule. Okay, then it has to be heated and cooled. Okay, some spaces are only heated, some spaces are only cooled, some spaces are unconditioned. That can be a mechanical room, for example. Some spaces are vented, but they don't have a heating system. And naturally vented only means that you have an opening and that's it, but you don't have any heating system. So make sure that you select heated and cooled, because this is what we did now. The space type, we can select here. You have all these options. By default, you have a building, but this is not enough. So if we're analyzing okay, here we have a classroom, a lecture training, a classroom, a penitentiary. Well, this is not a penitentiary yet, but we can click on this one. Okay, so this is a classroom, lecture training. Yeah, so if we are in an educational building, we can use this. And well, we can keep on working with this one or working with that one. Once we have defined this classroom, here we have a lot of parameters. The area per person. By default, Revit considers that this is the area per person, 16 square feet per person. Is it, well, I think probably with the full occupancy, we have this area, but we can specify how many people we have. Then we have the sensible heat gain per person and the latent heat gain per person. We have talked about this. This is to calculate the ventilation loads. We can leave this as by default. Probably this will change if we are working with other building types like fire station. Or sports area. Well, it doesn't change. That's the human activity. So I'm sure that if we find another, this can change. It changes the area, it changes, other parameters change. And that change, especially when we have sports facility. I don't find any sports facility here. So let's stick to the classroom. Then the lighting load density, we can leave this. That's the artificial lighting load. Yeah, we can say by default, we have this. And then we have the occupancy schedule. So that's important because here we can define this and we can change it. Okay, if we consider that from 0 to 6 a.m., there's nobody there. At 7 a.m., it's only a 5% of people or the 5% of the use of the building. We can change it. We can say that this is 35. And you see that that changes. Or we can say that this is only 5. Okay. So we can define the kind of schedule that we have. This is the school occupancy, 8 a.m. to 9 p.m. by default, but we can change that. Then the lighting schedule, again, so this is the artificial lighting schedule. If we consider that at this point, the natural light is enough, at noon, for example, we don't have any artificial light. So, and at 1 a.m. we don't. Okay, so we can always work with that schedule. And the power. So this is how many elements are the computers, the vending machines, anything. So we can always. I recommend you if we select the type of the building or the room or the space that we are working with, I recommend you leave all these as is. This you have to change. I have changed this one and I have selected always 20 CFM per person. This is the outdoor air per person. This is the ventilation load. So it's always 20 CFM. And by default, I think it's lower. Okay, so make sure that you change at least this one. It has to be. And we can define this in different ways. We can define the air per person, we can define the air per area, or we can define air changes per hour. I am familiar with this number, so I will define this one. And then the outdoor air method, I would select maximum by people and by area. Okay, so if by area I type 0, I make sure that this is the maximum. It is going to be always the people, okay? Because we can define either by people or by area. If this is the number that we are familiar with, the 20 CFM per person. So here we can define the maximum by people and by area, and those two can be 0. The heating set point is 70, that's fine. The cooling set point is 74, that's fine. And we can have humidification or dehumidification. Okay, but with this one, we select the space type and we have the classroom here. Okay, so you see that this has changed. And if we click here, now all these parameters have changed as well. Then the construction. We can, here we have to select building. If we have defined the walls, okay, so here we have defined the wall and we have the wall that we have already created with the R value above 50. Okay, so we have defined the walls, the roofs, and the floors. So on this construction, we select building. If we don't select the building, if we are using the default materials that we have in Revit, then you can select that the exterior walls are like this, or okay, so you can select all these options. It's overwhelming, so I recommend you define the building, and then you don't have to touch this. Define the building elements. And now people, that's important. We can specify the number of people, or by default, I think it's by space type. Specifying the number of people is more accurate. So how many people do we have in this room? We can type 20. Okay. And even we can specify the heat gain. If we are working with a gym, for example, or a sports facility, those numbers will be higher. In any other room, 250 and 200 for sensible and latent, it's fine. But we do have to specify the number of people. Okay. And here, okay, so let's see, or let's type something here. Okay, so we're going to specify for HVAC 10 watts per feet square, just for, yeah. So this is a number, but I want to specify something here. And here, let's specify 5 and see what happens. Well, when we are done with this, then you remember that we can analyze heating and cooling loads. We have the space here, and here, the building type is a school or university, because we have defined classrooms. You can select the location. You can select, okay, that is going to be important. The building service. And here we have a lot of options. Since we want to go electric, because in the TDS building everything is electric, we should use split systems. I would use split system with mechanical ventilation. Okay, because this is what the building is about. This building is electric. We have a mechanical ventilation. We have air handling units on the roof. And we have splits. If you look at the classrooms or the spaces without the false ceiling, you can see the split hanging from the slab. Okay, so this is what we have. Everything is electric. There are other options, but in other options, you have a burner, so we don't have a boiler, or we don't have a burner. Everything is electric, so just select this split system. The schematic types, we have to use building as well. So this is the same information that we had before. If we select building, is the walls that we have created. The report, okay. Save settings. And now heating and cooling loads, we can go to details. And if we go to details, we can select the space, and it should match with the options that we have selected here. So this is a classroom. The construction type is building. People, 20 people. I have selected 20 people. And the electric loads, the lighting. Yeah, so this is the same thing that we have selected. And then we can calculate. And this is the first report that we did. Okay, so here we have only just space, and you should be familiar with this. And we have a lot of information, but this information, as you can see, is just the peak load, the peak cooling, and the peak heating load. But we don't have any information about monthly performance or even daily performance. Okay. So is this useful? Yes. Good, because here by looking at the wall, the window, the door, the roof, we can look at these numbers. For sure, the windows is always the element with the highest heating or cooling load. This is cooling, this is heating. So this is the information that we, well, this is what we did on the midterm assignment. But now we're going to do something different. But this is good. So keep this one. Okay, so we have the first load report. But now we're going to work in this Analyze tab. We're going to work with this system analysis. So don't click on system analysis yet, because this works on a different way. Location, okay, so location is, you can specify location here, but you can also specify location in heating and cooling loads. This is the system zone. Sketch tools. Well, we have created spaces. If we didn't, yeah, if we hadn't created spaces, we would have to, yeah, but we have already created spaces, so we don't have to do anything here. But here, Well, I'm deleting the energy model because I have done this before. So I want to delete the existing energy model. But this is the first thing you have to do now. You have to create an energy model. Even before doing this, we have to check the energy settings. I know that this is redundant, but we have to check everything. So for the energy settings, we have to use the building elements. By doing this, we select the wall, the roof, everything that we have created. And then in advanced options, we have the HVAC system. We have to use something that, so we have to do this again. For example, the School of University, we have done this, we have defined the space, and now the building is School of University. Here we have the operating schedule, and this is different, okay? So we have to click what we want here. Is it 12 hours per day, 6 days per week? Or is it 12/7? Or is it 24/5? So we have to specify something different here. For the HVAC system, we have to specify again something different. By defining this space, this is a different analysis. This is not well done in Revit. So here we have to specify something different. So we have split and heat pump. Okay, so we don't have boilers, or we don't have heaters. It has to be something that has a split and a heat pump. So it's an electric system. The outdoor air information, we can edit at least. We have the same information here, it's 20 CFM per person. Sport category, this is very important. We have to click spaces here, not rooms, spaces. Because we have defined spaces, and now we have to export spaces. And then for the material thermal properties, we have defined building. Okay, so if we have defined building, we don't have to work with this. Now we click OK. So remember that this is the energy settings. And once we are done with the location and with the energy settings, then the third step is to create an energy model. And we have to create the energy analytical model. If there's already one and you have changed something, you have to delete the previous, and then you have to create another one. So create the energy model. And this is, since we only have a space, this is very simple. Okay, so we have created this building, and this is the analytical space that we are analyzing. And now, after doing all this, we can run the system analysis. Okay, so click here, and then we have two options: the annual building energy simulation and the HVAC system and loads simulation. We're going to simulate both. We can select both at the same time. So just select the first one and run analysis. And now in the background, it's calculating something. Since this is a very simple building with only one space, it will take a few minutes. But if you are doing this with TDS building, it can take hours. So that's why I recommend you do this first with something simple, and then we can move on to the complicated building. Okay, but as you can see, this is not straightforward. Revit, I think I've told you before, is not a software for energy simulation. It's a software for energy modeling, and it's great for that. And since we have the energy model here, or so we have the 3D model of the building, then we can use this for the energy simulation. There are other energy simulation softwares, but the interface for the 3D model, it's terrible. So that's why Revit is a good option. Now even SketchUp has an energy simulation tool. and I want to find out how this tool is because with SketchUp, I think modeling it's easier than in Revit. And there's another energy simulation tool in Rhino. Um, yep, we do have an energy simulation tool in Rhino, and this is the ARC Sim. This is a very good software that most of engineers are using. The problem is that we need to know Rhino and Grasshopper. Do you know? No. Okay.
I wish I did know.
I wish I, yeah. So I remember that I used Rhino when I was with my PhD back in 2000.
Wow.
And I used the first version of Rhino. It was quite good, but I haven't used Rhino since 2002.
Remember when I took CAD 2 and there was a student from, I think it was Saudi Arabia?
Yes.
She knew Rhino and she was teaching it for AIS.
I remember that, yep. I mean, I think there's a fight now in the world between Rhino and Revit. And it's Autodesk, and I don't know Rhino. I don't know what the company that develops Rhino, but it's like Mac and PC. There's Rhino and Revit. Does it mean that Rhino? I think Rhino works better in Mac, and Revit works better in the PC. This is something that you have access to Rhino. It's for free, again, if you're a Kent State student. But we have decided that we are teaching Revit. Maybe we can change in the near future, or we can have a workshop in Rhino. I don't know. Anyway, when it comes to energy simulation, this Rhino ARCH Sim, it's quite good. And I know a lot of engineers that are using this kind of software. Apparently, it's more reliable. Okay, so this is that's the key point. So this is Transys based, and Revit is Energy Plus based. So again, there's a clash between Mac and PC, between Revit and Rhino, and between Transys and Energy Plus as the energy model database. So this is using Transys. This is much more complicated, so that's why we are teaching Revit, because Rhino is more complicated than Revit, and Transys is more complicated than Energy Plus. Okay, so anyway, we'll see. Well, it has finished, and now we have an analysis report. You know that we have loads report and analysis report. So here, this is the energy report that we have created, and we have all this information, and this is overwhelming. Okay. We can have even this 20-year or 20 or 25-year analysis about the present value. This is again, we introduce this kind of economic parameters, and we can have the same not only with the PV array, but with everything. Okay, so we can see what the price of the building with all the systems and everything will be from 2011 until 2035. Why does it start in 2011? I don't know. In some place, we should have typed that we're in 2011. I don't know where. Okay, but that's the information that we have, and heating, cooling. This is the table of contents. This is the HVAC sizing summary. And I'm sure here somewhere we have information on a monthly January. Yeah, so we have a lot of information. Too much. Okay. It used to be easier. Things are getting complicated, and I don't think this is better than the first version that I used back in 2016. This is what Revit 2021 is doing when it comes to energy analysis. And yeah, I think it's too much. Anyway, this is the first analysis, and we can run a different one. We can go to HVAC systems. Let's see if this is easier to understand, but I don't think so. So what do I want? I want you to at least work with the spaces. Okay, so I want you to include all this information about the number of people in the space, about the use of the space, and then at least we have to generate these heating and cooling loads. And then I want you just try to generate this energy model and to generate this system analysis. Okay, you only have to do this. You only have to work with the energy settings, do the same thing that we have done here. Then you have to create the energy model, and finally you have to run the system analysis. Both of them, the annual building energy simulation and the HVAC systems loads. Okay, so I want both of them. It takes time. It's working in the background. Okay, so you can keep on using Revit, but if you're working with a TDS center, it will take forever. So I'm going to open the TDS building now. Oh, it's already open. Well, that system analysis is complete. We have both. It's here, but it's on the cloud. But let's select this. And yeah, we have another report here. That was the first one. This is the second one. And again, it's too much. But here we do have information on a monthly basis. But we have too much information, so that's why yeah, just analyzing one of these tables, it'll take a class to analyze one of these tables. Okay, so let's do it. Let's try to work with the energy settings. Let's run the system analysis and see what happens. Okay, but I want, yeah. So we have to work with this. Remember that we have already done this, but we are going to do it again because this week you will have to work with this building. Now we have, by default, we have the spaces here. If we look at the section, we see that the spaces are not, and that will cause problems. So on level 1, we can select everything. we can filter, we can select spaces, and since the building doesn't have double volumes, because I told you not to do the double volume here, we can, the upper limit should be level 2, and the offset is 0. And then on level 2, we have to select all the spaces. And the upper level is level 3, and this is 0. And now in the section, we can see that all levels are correct. Okay. If you want to see the levels, you have to go to visibility graphics, make sure that it's the mechanical, because levels are in the mechanical, the spaces are in the mechanical. And then we have to click here, interior and reference, like, and now we see this green. And if there's a space that it's missing, we can look here. So on level 2, we can do the same, visibility graphics, spaces, like. Okay, so there are a couple of spaces here that are not done. Doesn't matter. It's better. I think I told you that this, for example, this is the staircase. That space is not, we don't have a heating system on the staircase, but I think it's better if we analyze, create space. If we place the space here, up to level 3, 0. And then if we select this, we can go to a space that it's not occupied, and which is only naturally vented only. Okay, so this is better than not creating a space here. So make sure that when we have a mechanical room or something like that, if we create a space, we name that space as staircase 1. And make it unoccupied and just vent it naturally. Okay, so you know that we are going to analyze this one, so that's why I told you to analyze. This is the 201 studio. We are going to analyze the crit space, and we can analyze the room 203. And the CAD lab. And on each space, you have to define what we are doing. The CAD lab, it's occupied. The building, it's a classroom. Number of people on the CAD lab, 17. Yeah, makes sense. And what else? The mechanical flow, we are not working with this. It's occupied, people, electrical loads. So let's edit here, okay, 17, sorry. And yep. And then with this one, with this classroom, how many people? 20, maybe. Here, how many people? 50. Okay. And but make sure that they are all occupied, heated and cooled, and you are, at least you select the right amount of people that can be there. It's up to us, 30 people on the grid in the grid space. Yes, why not? Okay, and the rest of the, because we are going to analyze only those spaces on the second floor, and on the first floor we're going to analyze display spaces. We're going to analyze this workshop. And the lobby. Okay. So that if we run the heating and cooling loads analysis, we have all the spaces here, but in details, I don't think there's a warning. Okay, so this staircase, as you can see, it's a space that doesn't have a heating system. That's why it's red. And if we have defined the names, it should be here, the studio, the classroom, and all that. Make sure that we are working with all these. It's an office building. No, it's a school or university. The building systems is split with mechanical ventilation. Make sure that this is this way. And the building filtration I didn't mention before. Make it tight. Okay. And details. And then if we are selecting the workshop, make sure that the space type is be a classroom. Construction type, people, we can change the number of people here or there, I don't know, let's say in the workshop, 20 people. And then we can run the heating and cooling loads analysis, calculate. Okay, and now I'm not interested in the total heating load of the building. Well, we can be interested because now if we have the total cooling load and the total heating load of the building, this is something that we can use to analyze the PV array. But what I'm interested now is in this summary. Okay, so you have all the spaces here, but you only have to work with the grid space, for example, and this is the summary. And this is the information that we want. And here we do have infiltration and we do have ventilation somewhere. Yep. Okay, so we have all this information here that you have to copy on your report, but only about the spaces that we have generated. So I don't want this. Now you have to elaborate a summary with, I think 3 spaces would be enough. We can do this, the grid space, the studio, and either the CAD lab or the classroom. Okay. So you have to click here, then copy. Copy this on the PowerPoint. And now go back to summary of spaces, the studio. and finally the classroom. And we always need a cover page. Okay, so this is what we are doing now. We are analyzing this building, and we are analyzing at least 3 spaces. It can be the studio, the classroom, the CAD lab, and the grid space. And with this, I can see if things are right or wrong. And so this, you have to do this by using the heating and cooling loads analysis. And then you have to run this one, the system analysis. So start doing as soon as possible because it will take forever. But remember that first you need to set all these, especially the advanced solutions. Now this is a school of or university, it works. Make sure that you use spaces, you don't use rooms, you're using spaces. The building operating schedule, it's not a 24/7 facility, but I think it's a 12/7 facility. Yeah, that makes sense. And oh, and here we have to use something with, yeah, one of these. This is residential. It's not residential, but there should be another. Okay, so this one with the split and heat pump. After doing this, you can create the energy model, and this energy model is going to be more complicated. Okay. Because, well, we have to analyze all the spaces here. And once you are done this, then you can click the system analysis. I'm not doing it because well, I'm going to do it, but it will take, and then we need both, the first and the second one. So run analysis, and it will take hours, okay? The good thing is that you can keep on working with Revit, and even if you close Revit, it's analyzing this in the cloud. Okay, so if you want to shut down your computer or whatever, it will keep on analyzing, and at the end, in a couple of hours, you will have an analysis report, you will have something here. Now you do have something, but it's calculating. Okay, so by next Monday, you will have to submit something like this, the Revit analysis, and then you have to add the thing that we did last week, the PV array analysis. And then this is the heating load analysis. And finally, we will try to match the heating loads or the electric loads and the PV analysis that we have done. And we will do this by using PV watts and by exporting this data to Excel. And at the end, we will have a nice graphic. I don't know where the nice graphic is, but Okay, so we will do that with PV watts to calculate the energy production, and finally, by carrying out this Revit analysis, we will find the demand, and we will have to compare the energy production and the energy demand. In this building, the energy production is going to be like 30% of the energy demand, kind of. That should be the final result, because this is what they told me.